Hello, my name is Ajoba Tani, and today I will be presenting my project on enterprise AML compliance risk in cryptocurrency exchanges using Binance as the primary case study. For this project, I applied two analytical tools from our course, Bowtie Analysis and Bayesian Belief Networks. I applied this to model how financial, operational, and strategic risk interact to create large-scale AML failures. This presentation summarizes my findings and demonstrates how these tools help explain one of the most significant compliance breakdowns in recent digital finance. The core problem I'm analyzing is AML non-compliance in cryptocurrency exchanges. Crypto platforms face unique risks like global user bases, pseudonymous transactions, rapid movement of funds, and inconsistent regulatory obligations. My conjecture for this project is that AML failures in exchanges are driven not by a single point of failure, but by interconnected weaknesses, specifically in governance, KYC, and customer due diligence, as well as monitoring. I will show how these failures interacted at Binance and why they resulted in billions of dollars in penalties. The purpose of this project is to model enterprise-level AML non-compliance using established risk analytics tools. I chose Binance because the enforcement actions from 2022 to 2024 provide extensive documentation, making this a great real-world case. The scope of my analysis includes two risk modeling tools, Bowtie and Bayesian Belief Networks. These tools map out the causes, pathways, and probabilities associated with AML failure. Binance is the world's largest cryptocurrency exchange by trading volume. Between 2022 and 2024, Binance faced extensive enforcement actions by the U.S. Department of Justice and the Financial Crimes Enforcement Network for systemic violations of the Bank Secrecy Act. This culminated in more than $4.3 billion in penalties. Regulators had found that Binance allowed billions of dollars in transactions to move through its platform without adequate Know Your Customer verification, customer due diligence, or suspicious activity monitoring. Investigations uncovered internal communications showing that executives knowingly prioritized user growth and trading volume over compliance obligations. This issue matters for several reasons. First, cryptocurrency exchanges process billions of dollars daily, making them a target for illicit finance. Second, regulatory agencies like the Department of Justice, FinCEN, and FATFA have expanded enforcement significantly in recent years. Binance's $4.3 billion settlement was one of the largest AML cases in U.S. history. Analyzing such a major case helps us understand the enterprise consequences of compliance breakdowns and why they're so costly. This topic is directly relevant to our course because AML failures are multi-factor and interconnected, requiring structured modeling. It also demonstrates key course concepts like interdependency, risk propagation, and control effectiveness. By applying Bowtie and Bayesian belief networks, we can visualize and quantify how AML controls fail and how risks escalate at an enterprise level. This showcases the practical value of risk modeling tools we've learned. Here are some factors that contributed to AML risk at Binance and similar exchanges. Operational weaknesses included inconsistent KYC, insufficient staffing, and poor escalation. Technological factors included anonymity tools like mixers and VPNs, as well as limited use of blockchain analytics. Regulatory fragmentation also played a major role, and that's because Binance operated globally, and so it faced inconsistent standards across different jurisdictions. These factors interacted, which is why modeling is so important. Here is the bowtie model of AML failure. On the left, we have the threats. So under high-risk customers, that's where we put the weak KYC and CDD measures. Aside from those, we have poor transaction monitoring, the use of anonymity tools, and governance gaps, which include regulatory changes. At the center, we have the main event, the top event, which is enterprise-level AML non-compliance. On the right, we see consequences, penalties, reputational damages, liquidity risks, and operational disruptions. This structure here helps illustrate how control failures aligned to cause Binance's AML crisis. From the bowtie model, we can draw several key insights. KYC and CDD failures were the major upstream drivers. These weaknesses directly affected monitoring effectiveness. Monitoring tools were either ineffective or bypassed entirely by users employing VPNs or mixers. Governance failures, especially poor oversight and limited compliance authority, prevented Binance from addressing these issues early. Mitigating controls might have existed, but they were not strong enough to reduce the severity of the consequences. Here is the Bayesian belief network structure for AML risk. This model illustrates the conditional dependencies among risk factors. We see that governance affects KYC, which affects monitoring, and all three ultimately connect to AML non-compliance. Additional nodes like anonymity tools and regulatory complexity influence the upstream controls. BBNs are important here because they allow us to quantify risk and see how improvements in one area impact the whole system. Now, as you will notice, I did not use actual numbers or probabilities, and that's because I did not have access to actual numbers from the Binance case. However, I would still like to show this and use this model to demonstrate the methodology rather than representing actual Binance data. The BBN shows several important relationships. First, governance quality is the strongest upstream driver. Weak governance impacts both KYC and monitoring. Second, KYC strength directly influences monitoring effectiveness. The better the identity verification, the more reliable the monitoring outcomes. Third, monitoring effectiveness is the final barrier before AML non-compliance occurs. BBNs help us see how improving one control can reduce overall AML failure probability through network effects. For this project, I used a combination of regulatory documents, academic literature, and industry reports. The Department of Justice and FinCEN enforcement actions provided detailed descriptions of what failed and why. FATFA standards helped contextualize global AML expectations. And academic studies on blockchain analytics and AML machine learning provided me with evidence for how certain risk factors behave. Cross-referencing the sources ensured the validity and consistency of the models. From both models, we can conclude that AML non-compliance is a multi-dimensional enterprise risk. The Bowtie model showed that failures were systemic and not isolated. The BBN quantified how interacting weaknesses increase AML failure probability. Most importantly, governance quality emerged as the most influential risk driver shaping downstream controls. To validate the conclusions, I cross-referenced multiple regulatory reports and academic sources. I looked for consistency across findings and compared the case to other major AML failures. The logic of the Bowtie and BBN models was also cross-checked to ensure internal consistency. Even with data limitations, for instance, lack of access to actual Binance data, the triangulation approach ensured that the analysis remained reliable. My original conjecture was that weak governance, KYC, and monitoring significantly increase AML failure risk. Both the Bowtie and the BBN confirmed this. The Bowtie showed how upstream weaknesses converged to produce the failure. The BBN demonstrated that when these weaknesses interact, the probability of AML non-compliance rises sharply. Based on this analysis, the conjecture is well supported. In summary, the Binance case illustrates how AML risk becomes an enterprise risk when multiple controls fail at once. Bowtie analysis helped map the causal pathways, and BBN quantified risk interactions and showed why governance improvements have the largest positive impact. Overall, this project demonstrates the importance of holistic AML risk management for cryptocurrency exchanges. These are the key regulatory, academic, and industry sources that supported my analysis. They provided the necessary data to model the enterprise risk structure accurately. I would like to finish this presentation by saying thank you to everybody who watched my presentation and also showing gratitude for this course. It was a bit challenging when it came to learning the models for data analytics, but I'm very happy I took this course because I've learned things that would definitely help me along the career path I've chosen for myself, which is AML compliance and fraud investigation. I'm very grateful I got the opportunity to learn from other students, and I'm grateful for the time and energy the professor put in this course. I really appreciate all the comments on assignments and guidance for the project. So thank you everyone. I'm glad that I got to interact with you all, and I wish you all the best in the future.